All right, everybody. So this one is solving quadratic equations using square roots. Solve each equation using square roots. And we have 3 here. So 2x squared plus 14 equals 70. 4x squared plus 20 equals 16. And 3/4 x minus 1 squared equals 5. So let's look at the first one. All right, so when we have the way we know that we want to use square roots to solve quadratic equations is notice what's missing from each of these. All right, it's the x term. So we don't have the bx, right? We don't have a number x. We have an x squared. We have a constant, all right? But we don't have the x term, except for this, but here we have this squared. So this is another one. So if it looks like this, then it's easier to use square roots to solve quadratics. Okay, and we'll look at other ways to solve quadratics, but square roots work best for these. Okay, so let's try it. So what you want to do is you want to get the x squared by itself. So that means we want to get rid of that plus 4, and we want to get rid of that 2. So we want to undo those. Okay, so how do we undo a plus 14? Subtract 14 from both sides. Boom, cancels out. 2x squared equals, and we have 56. And, okay, so it's nighttime. I'm a little tired, so hopefully I do my arithmetic correctly. And we're going to, the way we get rid of that times 2 is divide by 2. Boom. We get x squared equals 28. Didn't give us a nice one. Oh well, that's okay. So here, now that the x squared is by itself, how do you get rid of a square? The opposite of squaring is square rooting. So we square root both sides. Boom, 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 boom. And remember in Algebra 1, whenever you square root both sides, you want to put a plus or minus every single time. Don't forget that plus or minus. So we get x. So these cancel out. The square root in the square cancels out. And we get x equals plus or minus the square root of 28. Okay, now if you leave like that, it's okay, but then we can simplify these radicals. Okay, so remember, to simplify a radical, you need to find out what perfect squares are. 2 squared equals 4, 3 squared equals 9, 4 squared equals 16, 5 squared equals 25, etc., etc., etc. Okay, so 4, 9, 16, 25. Do any of those go into 28? Yes, 4. Okay, so 4 times what equals 28? 4 times 7. So we're going to replace that with 4 times 7 and the square root. So the radical property, multiplication property of radicals states that we can break that up into square root of 4 times square root of 7. Okay, when we do that, square root of 4, I'll just write it over here. Square root of 4 times square root of 7. Square root of 4 is 2. So we have plus or minus 2 root 7. And that's that. Okay, so there's not just one solution. Okay, there's 2. A positive 2 root 7 and a negative 2 root 7. All right, that's where the parabola crosses there. Positive 2 root 7 and a negative 2 root 7. So that's what the graph would look like. Okay. Now let's look at B. We have 4x squared plus 20 equals 16. So it looks like the same as this. So that's what we want to do. We want to get the x squared by itself. So we need to get rid of that times 4 and the plus 20. All right. So which one do we get rid of first? The plus 20. So we're going to subtract 20 on both sides. Boom, cancels out. 4x squared equals -4. And then divide both sides by 4. Boom, we get x squared equals -1. And uh-oh, spaghetti. Here, notice that it says a number squared equals -1. Now, is it possible for a squared, anything squared, to equal -1? No. Like if you have -3 squared, all right, that's going to be +9. If you have 3 squared, that's going to be +9 as well. So no matter whether it's a negative or a positive, you'll always end up with a positive number. So here, this isn't possible. So whenever x squared equals a negative number, you know, hey, that's no solution. Because that's not possible. All right, that's that. And now let's look at C. We have 3/4 times x minus 1 squared equals 5. Now here, instead of getting the x squared by itself, we want to get rid of the squared term by itself. Okay, so that means we need to get rid of this 3/4. Okay, and how do you get rid of a fraction coefficient? You multiply by its reciprocal on both sides. Boop, boop. All right, multiply by its reciprocal. So multiply both sides by 4/3. And reciprocal, remember, is just flipping it upside down. Okay, so here we get x minus 1 squared equals 5 times 4 is 20, divided by, and 3, there's an invisible one, so 1 times 3 is just 3. Okay. And now that the squared is by itself, you want to undo it. So how do you undo a squared? What's the opposite of squaring? Square rooting. So you square root both sides. And whenever you square root both sides, don't forget that plus or minus. So these cancel out, and we're left with x minus 1 equals plus or minus. And we had the square root of 20 over 3. Now, notice that as soon as you see a square root of something, you want to ask, is it a perfect square? Is 20, when I square root 20, am I going to get a nice integer? No. How about square root of 3? No. You would get decimals, right? So it does a perfect square, 4, 9, 16, 25, go into 20? The answer is yes. Okay. So I'll do that up here. I'll do that on the side, I guess. So what times, I'll do it over here. What times, what perfect square goes into 20? 4, 9, 16, or 25? 4. So we have 4 times what equals 20? 4 times 5. Right? And now we can split it up. Okay, so I'm simplifying first. So again, you don't have to show this step. I just am, so that you can see where everything is coming from. Alright, and we're going to have to deal with this later. So we have x minus 1 equals plus or minus 2 root 5 over root 3. Alright, and now what we want to do is we want to simplify this, because we're not allowed to have a square root in the denominator. Ooh, this problem has many problems in it. So we're not allowed to have a square root in the denominator. So what we do, we want to multiply the top and the bottom by that squared. Why? Because square root of 3 times square root of 3 is square root of 9, which is positive 3. So that cancels out that square root. Okay. But when you do that, 5 times 3, that's going to give us 15 over 3. both sides. And don't worry, this isn't too bad. It's just x equals 1. Yeah, you just put it out in front of that plus or minus. Plus or minus 2 root 15 over 3. And that, as they say, is that. Okay, so that's that one. And here, solving a quadratic equation by factoring. So so here it says solve x squared plus 2x equals 35. So what we want to do first is we want to put it in standard form. Okay, so let's put this in standard form. That means we want to get everything to the left side, everything together. So let's subtract 35 on both sides. Set that equal to 0. You get x squared plus 2x minus 35 equals 0. And now, here let's label our a is 1, our b is 2, and our c is negative 35. Alright, so now we want to do the factors of a times c that add up to b. Factors of a times c that add up to b. Okay, so factors of a times c. So we have 1 times negative 35. And it's going to give us negative 35. So what are the factors of 35? Oh, those are nice. We have 31 and 35. And 5 and 7, that's it. That's why it's nice. We just have 2 pairs. And remember, we want to write it down twice. Okay. And we want to see what the signs are going to be. Are they going to be the same signs, or are they going to be different? And since this is a negative 35, right? A times c is a negative number. Negative, so different signs. Alright, so that means this is a plus, this is a minus, positive, negative, and negative, positive, negative, positive. Alright, so factors of a times c that adds up to b. 2b, and our b here is 2. So which of those adds up to 2? 1 and negative 35. No, that's negative 34. Nope, not that one. 5 and negative 7. No, that's negative 2. Ah, that's close. So let's try negative 5 plus 7. Yeah, that's positive 2. Ding, 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 ding. Alright, so we have negative 5 and positive 7. And now you want to put a times x plus p and a times x plus q. So our a was 1, so we just have 1x, and our p is negative 5. Our q is 7, so plus 7 equals 0 still. Alright, so that's factoring. Now we're going to solve it. So it's a product. They're multiplying each other, and it equals 0. The zero product property, and that tells us that we can just have x minus 5 equals 0, and x plus 7 equals 0. So one of these has to be true. So what we do is we solve for each of those. So we add 5 here. We get x equals 5. And here we subtract 7 and get x equals negative 7. Ta-da! Those are the two solutions. So that's where it would be crossing the x-axis, right? At 5, and negative 7. And that's that.